Okay, in this section, we are looking at two more tests. That's the comparison test. And this we will learn to use the comparison test or the direct comparison test to see if a series converges. And then we'll also learn how to use the limit comparisons test to see if a series converges. So before we get started, let's talk a little bit about the tests that we've already done. So we've done the geometric series, telescoping, nth term test of divergence, integral test, and p-series test. Today we are learning test 6 and 7. Okay, so I need somebody to tell me something about one of the first 5 tests.
I have a quick question.
Yes, Chule.
For the did you ever do the link for or the retest?
No,
Okay.
no, I haven't. Actually, I'm going to post today what I need you to do. So I can tell you now, you're going to send me an email and you're going to tell me which test you want to retake. Okay, so and you're going to have a certain words in the subject so that I know to look for that particular email. Okay, so I'll tell you what you're going to need to put in this subject. And then you can basically say exam number 1, exam number 2, exam number 3, exam number 4. And if you are really, really happy with your grades on the first 4 tests, then you can just say, well, I'll take exam 5 twice. I'll retake exam 5. Even though you haven't seen it, you can elect to do exam 5. And so whichever your higher score for exam 5, you'll keep. Okay, so I am going to, I will only be dropping your lowest score. And so you can only retake your lowest score. So if you got, that's the test that you can retake. It's the score that you got the lowest on, okay? Any questions about that? Yes, so if you missed the test, same thing. So whenever, so you're still, okay, so here's the thing. I'm still going to drop your lowest test score. But if you missed a test, you can tell me I wanted to, suppose you missed test number 4. Okay, then you would say, I'd like to take test number 4. So you will take test number 4. And then I will still drop. So so you're going to now have 6 tests. You're going to now have the first 5, 1, 2, 3, 4, and 5, and then your other tests, which you can elect to take. So if you missed test number 4, then this will slide right in there, and I will still drop your lowest score. So you still want to have 4 tests. So if you missed a test, that will be the test that you will take. Okay, so anybody that has missed an exam, that is the exam that you need to tell me you plan to take. All right, this is an opportunity for people who miss tests to be able to make up a test. And if you did not miss a test, you can retake a test. Okay. All right. Okay, back to my question. Can you tell me something about one of those first 5 tests? Anybody?
Excuse me, Dr. Lott.
Yes, Crystal.
Can you hear me?
I hear you, Crystal.
Can you hear me?
Yes.
I just joined, so I didn't really get to hear the whole part about the makeup testing. I just heard you say about if you missed the testing.
Right. So if you missed the test, then you will be able to, then that's the test you want to tell me you want to take.
Okay, so when are we supposed to tell you?
I'm going to put that on email. You're going to have a deadline by the end of this week to tell me which test you want to take. And after that, I am not taking any more requests, because once I make up the test, that's it.
Okay.
So, okay.
Okay, thank you.
All right.
Hey, Dr. Lott, did you do attendance?
I did. Who's that?
Antoine. I had joined at like 105. I think I joined right after you did attendance.
Okay, Antoine, and I think I missed Crystal.
I'm here
Oh,
too
yeah,
as
me
well.
Who's that?
Yeah, appreciate it.
Annalise.
And Elise, yep, you got marked absent. Anyone else? Okay, I'll go back in and fix the attendance. All righty. Okay,
Dr. Law, I actually do have another question before you start.
yes,
Is attendance, do you count attendance in our grades? I
I do
forgot.
not.
No?
No.
Okay.
I don't count attendance in your grade. Attendance is mandatory and it is expected of you.
Mhm.
So I don't give positive points for people who come and I don't take away points for people who don't show. It's just attendance. I take attendance because legally we have to take attendance. And because of the no-show and also because of the withdrawal drop and other things. So I take attendance because I have to, but it does not count in your grade.
Okay, thank you.
Okay. Any more questions? Okay, let's get back to my question. Somebody tell me something about one of these first 5 tests. Come on, I know you guys looked over this on the weekend. You studied it. You're all prepared today. Nothing? Y'all can't tell me anything about one of the first 5 tests? Okay, well, let's see here. Okay, we're going to keep moving. You guys need to review that. You need to review this. The geometric series test has a particular form. It is one of 2 tests that can be summed if it converges. It converges when the absolute value of R is less than 1. Telescoping series test is the one that looks like separated fractions or you use partial fractions. It can also be summed by finding the limit of the nth partial sum. The nth term test of divergence tells whether or not a series diverges, but does not give any information about convergence. The integral test, you set up a function that looks like a sub n, you take the integral. If the integral converges, the sum converges. P series of a certain form converges for p greater than 1. All righty then. All right, so let's do the direct comparison test. Okay, so here's the direct comparison test. I have 2 series, summation AN and summation BN. They're both series. It is always true after a particular part in the series that BN, the BN term is always greater than the AN term is always greater than 0. So if the summation BN, which is the larger series, converges, then the summation AN, which is the smaller series, converges. If the summation AN, which is the smaller series, diverges, then obviously a series bigger than that, the summation of BN, will also diverge. Okay, any questions about the verbiage? So let's do some examples. So here's the first example. Okay, so the first example is summation 1 over n minus 1. I know it looks weird that we're starting the series at 2, but I cannot start the series at 1 because n equals 1 will give me 0 in the denominator. So let's look at how we can do a comparison. So we're going to use the direct comparison test. So we're going to start off with n minus 1. So n minus 1 is clearly smaller than n. So that means then that 1 over n minus 1 is clearly bigger than 1 over n. So so now what we have is this. So we have an equal to 1 over n, and that's smaller than 1 over n minus 1, which I'm going to let equal bn. So now I clearly have an is less than bn. All right, and they're both positive, greater than or equal to 0. All right, so given this information, so now let's look at the series summation n equals 1, no, n equals 2, oh my goodness, to infinity of 1 over n. What do we know about this series? It looks like something we know. What does it look like? What does this series look like? What series is it? This series has a special name. Okay, so this series has a special name. What is it? What series is this?
Is it a harmonic series?
Yes, thank you, Lawrence. All right. So this is the harmonic series. And what do you know about the harmonic series? Does the harmonic series converge or diverge? We proved it using the integral test. This series diverges. So now we have this summation n equals 2 to infinity of 1 over n minus 1, or 1 over n, is less than the summation n equals 2 to infinity of 1 over n minus 1. Okay? We already said this series diverges. So this is divergent. Okay. So since the summation n equals 2 to infinity of 1 over n diverges by the direct comparison test, it is directly smaller I'm sorry, it is directly larger than something that diverges. So by the direct comparison test, the summation n equals 1 to infinity of 1 over n minus 1 also diverges. If it's the series is bigger than one that diverges, it also diverges. Okay, any questions? So notice I compared it to something I know, which was summation 1 over n. So with the direct comparison test, you're going to have two things to be able to state. One, which is the series that you're comparing it to and why that series converges or diverges, and then the use of the direct comparison test to show that the series you're looking at also diverges or converges. Okay. Let's look at number 2. Now, I think number 2 is really well suited for the next test, but we're going to use this test instead. Okay, so this one is 1 over n squared plus 6. So let's use the fact that n squared plus 6 is bigger than n squared. Okay, so that means 1 over n squared plus 6 is less than 1 over n squared. So I'm going to have an is going to be 1 over n squared plus 6. But that's less than 1 over n squared, which is equal to bn. And so there you have it, an less than bn. Okay, so I got what I needed. All righty. So let's examine this series. The summation 1 n equals 1 to infinity of 1 over n squared. All right, so let's examine that. Can you give me some information about that series? Summation 1 over n squared. Lawrence,
I'm sorry, what was the question?
can you tell me what kind of series this is?
That is a P series.
Good, all righty. So this is the P series. And what's P?
2.
All right, so that's a P series with P equal to 2. And what's the condition for a P series?
If P is greater than 1, it converges.
Good. All right, so now we have just shown that the summation 1 over n squared is convergent by the P series test because it is a P series. Hence, we have this, the summation n equals 1 to infinity is going to of 1 over n squared plus 6 is less than the summation n equals 1 to infinity of 1 over n squared. So this one converges. So the series we were looking at is smaller than something that converges, so it has to converge. Don't know what to, but we just know it converges. So since the summation n equal 1 to infinity of 1 over n squared converges by the direct comparison test, summation n equals 1 to infinity of 1 over n squared plus 6. That series also converges. Okay, so in the one of them, I made it bigger than something that diverged, and then I made it smaller than something that converged. Okay, so let's look at this series. Okay, so what is that symbol in the denominator? What is that symbol in the denominator? What does n exclamation point mean?
Not n?
Say that again.
Is it not?
No, not quite.
It's factorial.
Yes, it is. Thank you. Okay, so this symbol n factorial means n times n plus n minus 1 times n minus 2 all the way to 3 to 2 to 1. Okay, so that is a factorial. And you will need for the next section that n plus 1 factorial is to take n and multiply n plus 1 and multiply that by n factorial. So you will need that information in the next section. Okay, so what is 1 over 1 factorial? That's just 1. Okay. 1 over 2 factorial, what does that equal? Well, 2 factorial is just taking 2 times 1. So that's 2. 1 over 3 factorial. Is 3 times 2 times 1. 1 over 4 factorial. Anybody want to give me that?
4 times 3 times 2 times 1.
So you have to multiply this by, so this last one should be 6. Okay.
So that's going to be 24.
Yes, it is. And then 1 over 5 factorial. I think that's right.
It's going to be 120.
Good. And then 1 over 6 factorial.
360. Is it 7? Never mind, you write it down.
720, you're right. Okay, so now I see that I have the sum n equals 1 to infinity of 1 over n factorial. That is 1 plus 1/2 plus 1/4 plus 1/16 plus 1. All right, so therefore, watch this. 1 is equal to 1. 2, 1/2 is equal to 1/2. 1/4 is certainly less than 1 over 6. 1/5, which I think they skipped, but 1/8 is less than, oh, we didn't do that one, 727. Oh, it doesn't matter. 1/4 factorial is 24. 1/5 factorial is certainly less than, and I skipped one. This is 1, 2, 3 factorial. So this is 1/6. Okay, and then 1/5 factorial is less than 1/64. Nope, that's not what I want. That's not what I want. I want this to be 1/8. I want this to be 1/, so nope, still don't want that. Oh my goodness. Okay, the first one is 1, the second one's a half, the third one's a fourth. The next one is the 16th. The next one, so 1, 2, this should be 3 factorial. This should be 4 factorial. Okay, that's the pattern. All right, so what am I doing? I'm bounding, giving an upper bound to everything in this series. Okay. So if I look at the sum, n equals 1 to infinity of 1/2 to the n minus 1, I get 1 plus a half plus a fourth plus an eighth plus 1/16 plus dot, dot, dot. Okay, so as you can see, 1 is 1, a half is a half. This one is the one that's wrong. Now I know why I'm confused. This one should be 1 plus a half plus 1/6 plus 1/24. That's much better. Plus 1/120 plus 1/720. Okay, so if I pair the terms, the first term, they're equal. The second term, they're equal. The 1/6 is the 1/3 factorial, but it's less than the 1/4. The next term is the 1/4 factorial, but it's less than 1/8. The next one is 1/5 factorial. And that's less than 1/16. Okay, so as you can see, after n is equal to 2, they're all less than. All right. So when n gets bigger than 2, 1/n factorial becomes smaller than -1 to the n plus 1, n minus 1. Okay, so therefore, what can we say about, and this should be 1/2. Okay, so what can we say about this series? Summation n equals 1 to infinity of 1/2 to the n minus 1. So what does that series look like? That is the series above, but what do we know about it? What type of series is this?
The alternating series.
Okay, we haven't got to alternating series. Alternating series have a -1 that goes back and forth, back and forth. So this doesn't have a -1, but that is a good guess. Anybody else? Okay, you gotta notice A is equal to 1, R is equal to 1/2. This is a geometric series. And it being a geometric series, the absolute value of R, which is equal to the absolute value of a half, is less than 1, so it converges. Okay, so I now have this. I now have the sum n equal 1 to infinity of 1 over n factorial. Is definitely less than the sum n equals 1 to infinity of 1 over 2 to the n minus 1. Okay, does everybody see that? So if you go term by term, you can show that each term is individual and is smaller than its corresponding term in the other series. So now I have our series being bound by another series. Since this series converges, summation n equals 1 to infinity of minus 1, no, just positive 1/2 to the n minus 1 is less than the sum make this 1 over n factorial is less than the sum n. Oh, actually, I already wrote it's less than. I don't have to do that anymore. I can just say since summation n equals 1 to infinity of 1/2 to the n minus 1 converges. So that's the bigger series than the one smaller than it, which is the summation n equal 1 to infinity of 1 over n factorial also converges. Okay, any questions? Okay, so that is it for the comparison test. Let's do the limit comparison test. Now this one's a little meaty. And I say meaty because it's got a bunch of words. And if you are like me, I cannot stand definitions that are too wordy. So let's try to break this down a little bit. Okay. Okay, here we have the limit comparison test. All right, so the limit comparison test, you now have two series and their fractions, and you're checking to see if they both converge or both diverge. So if they're both going neck and neck, all right, so we have these two series, summation AN and summation BN are both series, and their terms are positive. After a certain point, AN and BN are both positive. So now the first part of the limit comparison test is the limit as n approaches infinity of AN over BN equals L. So always remember L for the limit comparison test, just a plain old L. If that limit is L and it's positive, then they both converge or they both diverge. Second one, the limit as n goes to infinity of Bn goes to 0. So I have something going to 0 and the denominator is convergent. The series with the denominator is convergent. then the series with the numerators or summation an will also converges. And then one other case, if the ratio of an over bn goes to infinity and bn diverges, then an diverges as well. Okay, so it's a meaty definition. You really mostly need to remember part A. Just be able to try to manipulate part B and C if you see it. Okay, so some examples. First example is rather easy. Okay. So we have this series we're trying to determine if it converges. And for the limit comparison test, I could try to see, I could do the direct comparison test on this one, but I'm going to do a limit comparison test so you can see how that works. Okay, so I always, if I'm going to use the limit comparison test, I know I need to compare it to something, so I kind of need to get an idea of what the series looks like when it gets really big. Okay, so I call that scratch work. So I do my little bit of scratch work, kind of like doing your homework so you know what's expected, okay? So I have 1 over (2n plus 1). And as n gets really, really big, that 1 is not going to matter. N's going to be so big that when you add 1, nobody's going to notice the difference. So this really looks like 1 over 2n, but that's simply just 1/2 times 1 over n. And then when I see that, I say, oh, as n gets big, it looks like 1 over n. I use the limit. As n gets big, it looks like 1 over n. Okay. So I think that's what I'm going to use as my bn, right? So an is my 1 over 2n plus 1, and bn is just 1 over n. That's all I need. I need to be able to do an and bn. All right, so now that I've found them, right? And again, I found bn just by looking to see kind of what an looks like as it gets big. All right, so then now I need to do the limit as n approaches infinity of an over bn. So that's the limit as n approaches infinity. An is 1 over 2n plus 1, and bn is 1 over n. So that's the limit as n approaches infinity of n over 2n plus 1. And that gives me infinity over infinity, which says, oh, that is prime time for L'Hopital's rule. Okay, so let's take the derivative of the numerator. So that's the limit as n approaches infinity. Derivative of the numerator is 1 and derivative of the denominator is 2. That limit is 1/2. That's my L. This is equal to my L, which is greater than 0. So L just has to be a positive number for this test. All righty. So now we know that the summation n equals 1 to infinity of 1 over n diverges because it's the harmonic series. Well, then, thus, by the limit comparison test, the summation n equals 1 to infinity of 1 over 2n plus 1 also diverges. So if I take the limit of the sandwich an over bn, I'm trying to see if they're going together to the same thing. So if they have a common ratio that looks like L, if one's going to infinity, the other one has to go with it. If one is going to a number, the other one has to go with it. Okay, so if they converge, both of them will converge. If they diverge, both of them will diverge. Okay, again, some of this is on the scratch work. Okay, so for this exam, this test, for this series, number 2. Okay, any questions for number 2? I'm going to take the square root of n, so here's my scratch work. So I'm going to take the square root of n over n squared plus 3. And I'm going to say, oh, if that gets really, really big, does that 3 really matter? If I'm at 10 trillion squared,
No.
that doesn't really matter. So this looks like the numerator is n to the 1/2. The denominator looks like n squared. So the whole thing looks like 1 over n to the 3/2 power. And that is what I'm going to call to be my Bn. So here, An is going to equal the square root of n over n squared plus 3. And Bn is going to equal 1 over n to the 3/2. So therefore, I get the limit as n goes to infinity of An over Bn. But when we divide by a fraction, we multiply by its reciprocal. So that's the limit as n approaches infinity of the square root of n over n squared plus 3 times n to the 3/2 over 1. So that's the limit as n approaches infinity. That's just going to give me n squared over n squared plus 1. Okay, so what I need you to do is prove to yourself that that limit is 1. So that's my L. All right. So since the summation n equals 1 to infinity of 1 over n to the 3/2, does this series converge or diverge, and why? Quickly, we are out of time. This series converges. P series. P equal to 3/2. Then by the limit comparison test, the summation n equals 1 to infinity, the square root of n over n squared plus 3 also converges. So you got to get this right on the test. All right, you gotta understand what this means. All right, I'm gonna post information about the makeup exam. And that's it for today.